Let's take, for instance, this ice block was at minus 10 degrees Celsius, for instance. So in that case, it is in what state of matter? Solid state of matter. Now I want it to change to liquid state. I will supply heat, isn't it? And when I start supplying heat, what happens? The temperature will begin to increase. Minus 9, minus 8, minus 7, minus 6, minus down to 0 degrees Celsius. Now here we have 0 degrees Celsius. Guess what will happen? Once the temperature gets to 0 degrees Celsius, this ice block will begin to melt. It will begin to melt into what? Water. Did you get the message? It was at minus 10 degrees Celsius, and then we started heating it. The temperature started increasing. It was increasing. But when the temperature got to 0 degrees Celsius, something started happening. The ice block started melting into liquid. At what temperature? 0 degrees Celsius. Despite we were supplying heat, when it got to 0 degrees Celsius, the temperature was no longer moving, but we were still supplying heat. Unlike when we were supplying heat, it was moving from minus 10, minus 8, minus 7, minus 6 to 0. But when it got to 0 degrees Celsius, we were still supplying that same heat, but nothing was increasing. There was no sign of increase in temperature. The temperature remains at 0 degrees Celsius. Why? The reason is because the other heat that you are supplying to this ice, that heat is used to break down this ice, to convert them into what? Liquid state of matter. And that heat is not seen or observed in our thermometer, because that heat was only used to break down this solid into liquid. Now that heat is what we call latent heat. So what do we say is latent heat? It is the quantity of heat that is supplied or removed from a substance for that substance to change from one state to another without a change in temperature. Next, we'll be talking about latent heat of fusion. In the case of latent heat of fusion, it is almost the same thing, but in this case, we are changing solid to liquid. But in the case of latent heat, you are changing anything from one state to another state. But when I say latent heat of fusion, latent heat of fusion, in this case, we are talking about the amount of heat that is supplied to a substance. Let's say this is my ice. The amount of heat supplied to a substance to change this substance from solid state to liquid state. The amount of heat supplied to a substance to change it from solid state to liquid state without any change in temperature. That heat is called latent heat of fusion. Now, how do we calculate latent heat of fusion? Before we move, let us understand what we call latent heat of vaporization. Remember, when you are heating your ice, it gets to 0 degrees Celsius. At this state, only change of state will take place from solid to liquid. We use ml. I will explain that later. Now, when it gets to water, let's say the temperature might be increasing to 10 degrees Celsius to 50 degrees Celsius, and when you get to 100 degrees Celsius, guess what happened? The water will begin to change towards water vapor. So this is water vapor. Water vapor. So the question I'm asking is, at what change liquid, at what temperature will water begin to change to vapor? The temperature is at 100 degrees Celsius. Now let me explain this in a nutshell. This is my water vapor. This is my ice. At what temperature the ice started melting to liquid? 0 degrees Celsius. And when it melts, the temperature begins to increase from 0 to 10 to 20 to 30 to 40 to 50 to 60. Remember, at this temperature 10 to 90 or 99, the substance is in what? Liquid state of matter. Is in liquid state of matter. In liquid state of matter. But once it gets to 100 degrees Celsius, no. the heat is now used to change this liquid into water vapor. So remember, in this calculation, there are two important temperatures you are going to be dealing with that you have to be very, very careful with. 0 degrees Celsius and 100 degrees Celsius. Sometimes they may say boiling water. So when they say boiling water, indirectly, they have given you the temperature, which is at 100 degrees Celsius. Calculate the amount of heat required to change 5 kilograms of ice to water. Here is my ice, 5 kilograms. At what temperature? 0 degrees Celsius. What happens once the temperature gets, as we are supplying heat? Once we supply heat, this 5 kilograms of ice, the heat gets to a point that the temperature begins to reach 0 degrees Celsius. When the temperature gets to 0 degrees Celsius, what happens? The ice begins to melt into liquid. Now, this point where the ice melts to liquid, there will be no change in temperature. The temperature will still be at 0 degrees Celsius until all the ice have finally melted. That is when the temperature will begin to increase. But in this question, they are only asking you what is the amount of heat that is required to change 5 kilograms of ice or to melt 5 kilograms of ice. The heat required is H equals to M times M. What is my M? The mass of the solid, which is 5 kilograms. What is my M? The latent heat of fusion of ice. Every substance like substances like solid and like ice and water, water vapor, they have the latent heat of what? Fusion. Now the latent heat of fusion of ice will be given to you. Let's say the latent heat of fusion of ice is 390. For instance, I like using 3. Okay, let's make it easy. Let's say the latent heat of fusion of ice, let's say is what? 30. For instance. So calculate the quantity of heat required to melt 5 kilograms of ice. The quantity of heat was just H equals to the mass of heat times the latent heat of fusion of ice, which is what? 30. And my answer is going to be what? 150 joules. Next, calculate the quantity of heat that is required to change 5 kilograms of ice to a temperature of 10 degrees Celsius. Now listen to this question. After you melted the ice to liquid, you were still supplying it, then the temperature started increasing to what? 10 degrees Celsius. So at this point, the temperature is 10 degrees Celsius. What is the total amount of heat you supplied to this ice that changed it to liquid, and the temperature of that liquid got to 10 degrees Celsius? We will now see in this case. The heat supplied was the heat that was needed to melt it, which is ml, plus the heat that was needed to change this liquid from 0 degrees Celsius to 10 degrees Celsius. And in this case, remember, it's no longer ice, it is now water. And remember, heat is, in terms of heat supply, equals to NC theta. So, plus the heat required to change this water to 10 degrees Celsius is going to be what? NC theta. Now, what do? Heat equals to what? The mass is 5 times the specific capacity, which is 30, plus the mass also is still the same, ice is still 5, times the specific heat capacity is 4,200, times what temperature did it increase to 10 degrees Celsius. So we just go 5 times 30, 150, plus everything, you multiply everything here. Let's say 5 times this, you add everything, your final answer should be what? In joules. Now you are going to do this simple question for me. Calculate the quantity of heat required to change 3 kilograms of ice to 3 kilograms of ice to water at 70 degrees Celsius. Make sure you do that. In a nutshell, remember, latent heat of fusion or latent heat is the quantity required, is the quantity of heat supplied or removed from a substance to change it from one state to another without any change in temperature. And then latent heat of fusion is the quantity of heat supplied to a substance that will cause a substance to change from solid state to liquid state.